In this lesson, we're getting into still our similarity, but now focusing on concepts that deal with concepts of similarity and the proportional sides with our midsegment and triangle proportionality theorem. Now, this first question, though, is review. So I would suggest go ahead and pause the video and then do this on your own. And here we go. So here you just had to identify, and we'll label, so like A, B, C, you had to identify and calculate this side lengths. So like right now, the original size of AB is just 3 units, right? Counting 3. Then here, AC is just 4 units. Again, counting 1, 2, 3, 4. So then here to calculate BC, well, that's just Pythagorean theorem. 3 squared plus 4 squared is equal to c squared because you do have a right triangle here. So that means that BC, when solving this, you get the side length of 5. So then here, you then had to dilate by a scale factor of 2. So like A was at 1, 2, now it's going to be at 2, 4. So here's A prime. Then B is at 1, 5. So now it's going to be at 2, 10. So here's B prime. Then C was at 5, 2. Now it's going to be at 10, 2, or 10, 5. Oh my goodness, 10, 4. Sorry about that. Here is C prime. And here is our enlargement. Now, with our enlargement, we're creating a similar figure. So as you will see, now notice we still have a right angle here at the A and A prime. So notice that corresponding angle here stayed the same. Then here are side lengths now. Notice this is why we have similar figures. Keep in mind we had a scale factor of 2, right? Now notice what is the side length of our new AB prime? Well, 1, 2, 3, 4, 5, 6. So notice what happened to the original side length as well. It doubled by the scale factor. So again, AC prime, 1, 2, 3, 4, 5, 6, 7, 8. So notice here, it doubled. So then if we wanted to use Pythagorean theorem, right? A squared plus B squared is equal to C squared, or 6 squared plus 8 squared is equal to C squared. When you calculate, you will get 10. So notice how with that scale factor, that is how we're creating the similar figures. So notice the corresponding sides are proportional using the same scale factor, but notice the corresponding angles. Did we also double that by a scale factor? No, they stay the same. So like here, our corresponding angles are congruent. So like here, if angle B was 40 degrees, then guess what angle B prime is going to be? 40 degrees. So here, if angle C is 50 degrees, then guess what C prime is? 50 degrees. So that stays the same. So then here, if we now taking away the grid, right? It's all the same concept. If I wanted to know what was the scale factor going from NPS to, so order matters, right? So if it's NPS, then it's going to be what? MLJ. So MLJ. Oops, sorry, MLJ. So notice here how NP is corresponding with ML. So this is saying we are going from 24 to 60, right? We're going 24 to 60. So then another side length, right? Well, PS. PS 30 is corresponding to LJ, right? 75. So now notice what is the similarity factor. So go ahead, pause the video, and go both directions to identify the scale factor. And here we go. So now notice our scale factor, right? We went from 24 to 60, which again, if you recall, we put that final over the original. 60 divided by 24 is 2.5. So let's check it. We went to 75. That's our final. 75 over 30, you also get 2.5. So 18 times 2.5 is 4.5. So our scale factor, right, enlarging is 2.5, which means Same thing. If we go from MLJ now to NPS, we're now starting at the large and now getting smaller, which is our reduction. So that means now we're going the other direction, right? We're ending at 24. So now 24 divided by 60, and you get that scale factor of 0.4. Then if you continue it, right, 30 divided by 75, you get 0.4, and 18 divided by 45, you also get 0.4. So that's how we know, right, that similarity and that factor here. So now talking about and using our similarity here, we've got what we call the triangle proportionality theorem. The triangle proportionality theorem states this: that if I have a triangle with this segment here that is parallel to the base, then that means that the sections that are created on the sides are proportional. So this is what we were talking about here, where we had our proportions, right, to create our scale factor. So that means this side, AE to EB, that is proportional to AF and FC here, right? So again, we are creating our proportion. Like for example, if I wanted to verify here that DE is parallel to BC, we create a proportion, right? So here I've got AE, which is 8, over EC, which is 12. This is its own proportion, right? The sides are proportional. So 8 to 12 is equal to, so then if we put 8 first, what do we have to put first? 10, right? Because they're corresponding here from that same top value. So 10 to 15. So now here to C, we cross multiply 15 times 8 and 10 times 12. So 15 times 8 is 120, and 10 times 12 is 120. So yes, they are parallel because the sides are proportional. So then if we wanted to find a missing value, right? So let's say US. So I'll put this as my X here. So now we are given, notice, right, that UV is parallel to ST. So we can use now the triangle proportionality theorem. So here we go. So if I've got 10 to 4, so 10 to 4, which means what do we need to put first here for this side? 14, right? So 10, so 14 to X. And now we cross, multiply, and solve for X. So 10 times X is 10X, and 14 times 4 is 56. So now when you divide by 10, you get X is equal to 5.6. So go ahead and pause the video and try this third one on your own. And here we go. So notice you're solving for Pn, so I'll put X here. So here we are given they're parallel, so 5 to 2, so their sides, they're proportional, which means if we put 5 first, you should put X to 3. Now we just cross multiply and solve for X. So 15 is equal to 2X. Divide by 2, you get X is equal to 7.5. So now the midsegment theorem. The midsegment theorem states that if DE is parallel to AC and B and E are midpoints, right? Notice how here, for example, D cuts AB into two congruent pieces, and E cuts BC into two congruent pieces. So this is a double. So again, the midsegment, if this is not only parallel, and it's going through the midpoint. And that means here that DE is half of AC. So if DE is 5, then AC is 10. So it is exactly half of the side that it's parallel to. So like here, for example, and sorry, this got cut off there, ST is a midsegment. So we know it's going through the midpoint in parallel. So if PQ is 46 inches, then that means what is the value of ST? Half of 46, which is 23 inches. So go ahead and try 5 here on your own. And here we go. So now notice QR is 28. So this whole side here is 28. XY here, so this piece here was 5 inches. And PQ, the entire side here, is 9. So 9 inches. So now notice we're solving for these missing pieces. Keep in mind, remember, whatever is parallel, that mid-segment here, notice we're given mid-segments inside, are half of the side that's parallel to. So PR, well, notice PR is parallel to XY. So if XY was 5, then PR here is 10 inches. So then QY, here we go. Well, QY is this section here, which is just, if you think about it, half of 28, right? Because this is, Y is the midpoint. So that's why QY is 14 inches. Then XZ. Well, XZ is here. Well, what is XZ parallel to? XZ is parallel to QR. So if QR is 28, then XZ is half of that, which is 14 inches. So then YZ. So YZ is here, which is parallel to QP. So if QP is 9, then YZ is half of that, which is 4.5 inches. So little different now here because we're going to also include the angle. Now notice in this one, BD, right? So we're looking for BD first, given the information. So what side is BD parallel to? Because notice it is a mixed segment, right? Because it's cutting these two sides into two congruent pieces. BD is parallel to AE, which is 17. We just need to take half of 17, which is 8.5. So now let's look at AC. So AC here, which is this, is parallel to the mid-segment 6.2. So now we just need to double it, right? So 6.2 doubled is 12.4. So now here, we're looking for the measure of angle CBD. So angle CBD, so I'm going to go ahead and erase this information here. Angle CBD, so CBD is here. This is the angle that we are looking for. Now, what angle are we given? We're given that this angle here is 26 degrees. Now, here we are given that this angle is what we are looking for. Now, notice, keep in mind that these two sides that enclose it are what? Parallel. So here we've got our transversal and then our parallel lines here. So what is the relationship between these two angles? They are alternate interior. So if this angle was 26 degrees, then the measure of angle CBD is 26 degrees. Go ahead and pause the video now and try 7 on your own here. Here we go. So we're looking for JL first. So JL, which is here. So what is JL parallel to? What side? PN, the mid-segment, 36. So if PN is 36, then JL is 72. So now PM is here. Well, PM is a mid-segment, which is parallel to KL, which is 97. So we just now need to half the 97 here to get 48.5. Then last, we're looking for the measure of angle MLK. So let's look to see where it's located, right? So the measure of angle MLK. So we're looking for this angle here. Now notice we're given this angle here, which is 102 degrees. So now notice this one's a little different, but if I were to identify, we have these now pairs of parallel sides here, right? Along our transversal. So what is now the relationship between these two angles? They're corresponding, and corresponding angles are always congruent. So if this angle is 102 degrees, then the measure of angle MLK is also 102 degrees.